concerning this, free radical reactions are possible. These two hydrogen can replace with chlorine, can go up to CCl3. Electrophilic substitution is possible. So one example is pedograph alkylation to dispersion or dispersion electrophilic substitution. Nucleophilic substitution, this chlorine can get away with Cn minus with HCN. So that's also possible nucleophilic substitution. Hydrolysis is also possible with sodium hydroxide. That chlorine can get away and joins this OH minus. That's also SN reaction. All four are possible. 146, answer 5. Hundred 147. L is alkyl bromide reacting with alcoholic KOH. Alcoholic KOH supposed to convert this bromine to a double bond. That is elimination reaction. It is in the compound M. So the double bond is reacting with HBr, mean again it is making this bromine. They say L and this final N are isomers of each other. Compound N, when reacted with aqueous KOH converts this bromine to OH. Then tertiary alcohol. To be tertiary, there are supposed to be 3 groups joining into one single carbon. 3 groups joining into one single carbon. We can forget these 2. You have these 3 conditions. Here, see, you have all these 1, 2, 3, 1, 2, 3, and 1, 2, 3. But we cannot go with 4th and 5th one because to remove this bromine. So this is the next carbon. This blue one is the next carbon. But blue carbon doesn't have hydrogen to make the double bond. So that's impossible. So the only possibility is number 3. So that you are adding alcoholic KOH, gets a double bond, addition of HBr, now bromine comes to the middle, KOH aqueous, bromine become OH, which is a tertiary alcohol. L and M are isomers of each other. This is L, this is M. See, bromine here, now bromine in the middle. These are position isomers. 147, answer 3. And 48. Consider this reaction. This is chain extension reaction. MgBr gets with this hydrogen so that this CH3CH2 is joining with this blue CH2CH3. Chain extension. The product is butane. Yeah. CH3CH2. This is the nucleophile. This is the nucleophile. Green is the nucleophile. Reacting with CH3CH2I. With respect to CH3CH2I, the reaction is SN. 148, answer 3. 149. Alkyl halide with alcoholic KOH. See, then this CX1 is polarizing towards halogen. So it is dragging electrons away from this CH. So that this hydrogen with lack of electron, this OH minus is attacking onto this hydrogen. So this is alpha, this is beta. So we call it a beta elimination. So you remove this HBr. So the most possible OH minus is not attacking onto this here. This is wrong. The correct depiction is supposed to be this one. Second one again supposed to come here. Third one arrowhead is wrong. Fifth one again supposed to be here. This is again supposed to be here. Okay, so the only possible answer 149, answer 4. I'm just showing the correct one, okay? $150. This is not exactly ionic or covalent halogen. Here I'm just showing whether they have the ability to going through SN or not SN. If they are going through SN, these halides can release to the medium as ionic halides, so they can participate whatever the reaction. Example, silver nitrate, silver halide. But covalent halides mean they are not releasing halogen to the medium. Okay, tertiary, acid halide, benzyl halide, allyl halides, benzene diazonium halides, quaternary ammonium salts if they have chlorine, bromine, iodine, and also greener. So whenever they are having this halogen, when the halogen is releasing to the medium, that halogen can make precipitate. But no SN, primary, secondary, aryl, and vinyl. Secondary is problematic, but usually I have taken it to this side. I didn't give this a short note because I don't want you guys to misunderstand this. This is not ionic or covalent halide. This is the way they are reacting or participating through SN reactions. Understood? Okay, copy this. In my short note, I have this, but I haven't given this to you. Both are stable. We never compared those two, but for me, it's a vinyl chloride because it gets this double bond nature. Ethyl chloride doesn't get double bond nature. And ethyl chloride participates SN. Vinyl chloride, no SN. Question number 150. All which rapidly react with water at room temperature. Let's forget this acid anhydride. That's also faster, but with non-examples, you can get all these three. The best example is this one. Diazonium reacting faster, acid halide really faster. Grignard is unstable with water, so the reaction is faster. Ether reacts, but ether reaction, sorry, ester hydrolysis without acid any driving force is slow. This is not even dissolving in water. 150 answer 2. See, I have shown you guys all these 3 reactions of 2. Number 1, number 2, and number 3. Reactions with water. Question number 151. Okay, to make greener, this hydrogen disturbs, acidic hydrogen, this alpha hydrogen disturbs. Okay, only possibility is number 3, 151, answer 3. Now, Disha, did you have a head wash in the morning? When you were having this loose, I thought you had a wash. Make it loose, it's okay. You have AC, you're not getting sweaty inside. All right, 152. With OH minus, order of substitution of chlorine. This is aryl halide part. Okay, this intermediate, that's really unstable and double bond nature here. So you cannot break this bond. So that's A, lowest one is A. Then moving to C, this is acid halide part. And the reaction goes this way, acid halide OH minus. Reaction goes this way to make carboxylic acid very easily. Plus charge of this carbon is really high with this electron dragging group. And so that halogen is very easy leaving group. So reaction is really faster. And this is also okay. This chlorine is joining onto this tertiary carbon, SN1. So tertiary carbocation is stable. So this reaction is possible, but less reaction than acid halides. So B comes into the middle. 152, answer 4. Question number 100, is it not done? Okay, just copy down everything if you want. Ask me to hang in. I can do that, don't worry.
The order is
Order of? In order of case of substitution the chlorine atom. Maybe increasing, decreasing. That's just got the way they have given. Higher supposed to be C, lower supposed to be A. Either increasing or decreasing. Only possibility is only the exact answer is 4. You cannot get any other answer. They were not saying increasing or decreasing. 153. Correct statement regarding this compound. This is an aldehyde. You have this aldol alpha. These two here. But why is this beta? Okay, why is beta? It undergoes an electrophilic addition. Nucleophilic addition. This is a reaction. Cn minus is a nucleophile, A wrong. Acidic character is to beta, not alpha. So number B is wrong. Sodium borohydride. Sodium borohydride. Converting this to ONA. But you have to add methanol to get the alcohol. So need hydrolyze to get alcohol. It is not showing that. Only in the presence of water or methanol, this is going to final alcohol. That's why it is wrong. Okay, see, be really alert. Oxidation when reacting with this actually is the tolerance. Tolerance, you are oxidizing this, reducing silver plus to silver. Only D is correct. 153, answer 5. Moving on to 154. Vinyl chloride is this. It has this resonance stability, high S character percentage. So you get this double bond nature onto CCl. So it's really hard to break this bond. So no SN. But this one, alkyl halide, is participating to SN2 reaction. Vinyl chloride undergoes nucleophilic substitution reaction more easily. It's actually not undergoes than ethyl chloride. So first statement is totally wrong. Although the bond between the carbon and chlorine in vinyl chloride has a double bond character. See, true. This property is not present in ethyl chloride. Ethyl chloride doesn't have such thing. That's true. 154, answer 4. Moving to oxygen-containing compounds, and the first part is with alcohols. True for alcohols. Alcohols react with PI3. We know it is reacting with PCl3, so we can assume it's reacting with PI3. Let's consider other. Directly Br2, no reaction. This is the iodoform reaction. It is out of syllabus. We never done that. Sodium hydroxide alcohol, no reaction. Alcohol acid is less to react readily with sodium hydroxide. Answer 1. 155, answer 1. Reacts only with sodium, okay? No reaction with sodium hydroxide, so that no reaction with cesium hydroxide. 156. These two most suitable initial steps for conversion using this initial compound is tertiary alcohol. OH, halogen, isn't that easier? OH converts to halogen, then halogen to CN, addition of any acid to COOH, or even chlorine to Grignard, CO2H2O, COOH. Anyway, we have only one single possibility, number 3. Number 3, 156, answer 3. Are you guys okay to do the class during before the last week? Last week anyway, I'm going to send you guys the recording. Before that week, maybe we're supposed to do the class without AC because they're going to detach this to bring to the new building. Chittak dukkindra hadara sakmedi. Yeah, you are going to a beautiful class hall. I love it. I love to start my career there rather here. But still, lot to do. Finish. Okay. 157. Okay, only one single reagent you have to convert primary alcohol to aldehyde compounds, that is PCC. This is pyridine, HCl and CrO3, pyridinium chlorochromate. This is a PCC. Primary alcohol to aldehyde. Hundred 158 to synthesize this compound. This compound is, I'm not sure, so I'm just writing it as this. Starting from this one here. This is the initial. Remove the OH, then just the Marconic of HBr. Hydrogen goes to the carbon where hydrogen is high. 158, answer 3. Okay, 159. Which of the following cannot be used to distinguish between secondary alcohol and tertiary alcohol? Okay, tertiary alcohols, no oxidation, so no reaction with potassium dichromate, permanganate whatsoever. This is the Lucas reagent, but phosphorus trichloride, exactly same thing happening with the Lucas reagent, but there is no turbidity observation if you don't have this zinc chloride, this catalyst. That is the answer. No catalyst, number 3. All the other 1, 2, 4 are strong oxidizing agents. They oxidize only alcohols to ketones, secondary alcohol. So that 159, answer 3. Hundred 60, butanone can be obtained. Butane 2-ol This is a butanone, so you're supposed to get this compound. From this one, strong oxidizing agent ketone. 1-ol is this. It is giving the carboxylic acid. This reduction CH2OH. Butanoic chloride is this. That's again get this terminal OH, not this carbonyl. Only A is possible. 160 answer 5. (161) Ethanol labeled O18 and unlabeled ethanoic. So we did this mechanism for chemical kinetics. OH of carboxylic acid gets away H of alcohol to make water, so that the labeled alcohol oxygen just still existing in ester. Water doesn't have O18. And also remember O18 is not radioactive, 16, 17, 18 not radioactive. Ester has O18 and this ethanoic acid, remaining ethanoic acid even in the medium, CH3COOH, that doesn't have labeled oxygen. So CD correct, 161 answer 3. O18 is not radioactive. (162). This is again primary to aldehyde. Answer 3. Answer 3. We did this to 157. I actually made these questions because the given answers are out of syllabus. 163. Concerning these two compounds can be qualitatively distinguished using PCl5. PCl5 is supposed to give RCl, so OH to ClCl, but we cannot distinguish. This is okay. They are making 2 different esters with these 2 acid halides, but we know this present smell is there, but we cannot distinguish between this CH3 and this group with esters. This one is possible with Brady's oxidizing CH3OH to carbon formic acid, but this one to ketone. So this can oxidize further to this 2,4-DNP no reaction, but here this gives this yellow-orange precipitation. That is the answer. Failings barium hydroxide, failings reacts with aliphatic aldehydes and formic acid only, failings. 163, answer 3. Number 4, barium hydroxide is not acceptable. Acidity of alcohol is not enough to react with barium hydroxide or sodium hydroxide. Nadisha, can I move on? 164. Okay, this is the reaction they are expecting. This secondary alcohol is converting to ketone. For that, you need any good oxidizing agent plus acidic medium, okay? Acidic medium. PCC also possible. Uh, Tolerance reacting only with aldehydes to COO. Bromine and chlorine are okay, but not that strong to react with secondary alcohol. So no reactions with them. So 164 answer 5. 164 answer 5. 165 is again extremely easier. Okay, so that we know, formation of alkane, an easy method is through Clemmensen reduction. But for that, we have to oxidize this. We need any strong oxidizing agents and then the Clemmensen reduction. 165 answer 2. 166. An organic compound X, molecular formula C8H8O2, and they are showing all these with benzene rings. So this is supposed to have benzene ring. Produces a gas on reacting with sodium. See, I have given all these reagents reacting with compounds. Terminal alkyne, alcohols, phenols, carboxylic acids. Any of those you cannot see in the first one. Okay, I'm going to move on. Orange color precipitated with red is carbonyl, aldehydes or ketones. We have a couple. Give aromatic dicarboxylic. To give dicarboxylic, this is mono-substituted. We have to avoid this one, number 5, other 4. Does not produce the gas when mixed with sodium carbonate. So it cannot have COOH. No A. B is not producing in this one. And also has COOH, one substituted. And this one, if you oxidize, this part and this part both supposed to get oxidized, but OH cannot oxidize. Ether is not oxidizing, ether is very inactive. So the only possibility become this one, number 3. 166, answer 3. Products are asking. Okay. A and B. A, acidic potassium permanganate dichromate whatsoever. So this both can oxidize to this. But they were not given that as the answer for any of these 5 answers. But they were taken this one, leaving this as it is. So I'm going to go as it is. This is converted into CO. Okay. This CO can oxidize to COOH, but they were not taken that. Sodium borohydride doesn't do anything with this. Just leave it as it is. But this group is reducing to this. So 167, answer 3. Moving on. 8. 168. The boiling point of propanol is this compound, propanol, and 2-methyl propane is this. Dipole, and London, dipole is greater, so supposed to be higher. The statement correct. Propanol molecules cannot form hydrogen bonds amongst themselves. Yeah, direct OH, NH, FH. But that's not the reason. Reason supposed to be the comparison between dipole, and London. They are not giving the comparison between these two, so no explanation. 168, answer 2. Butane 2-ol and 3-methyl-propan 2-ol. See, once you draw secondary alcohol, tertiary alcohol, instant turbidity, turbidity after 10 minutes, not the shorter time, time is longer for secondary, turbidity after 10 minutes. Tertiary carbonium ion are more stable than secondary due to inductive effect. That's true. 169, answer 4. And 169, answer 4. (170) Propanol. Distinguish between propan 2-ol. Propanol is a ketone. This is the propanol ketone. And propan 2-ol is alcohol. There are supposed to be different lot of methods. Boiling with acidic dichromate. Only alcohol is showing the color difference. Zinc chloride concave Cl. Only secondary alcohol gives this turbidity after 10 minutes. Failings, only aliphatic aldehydes goes from RCHO to COOH, brick red precipitate, not ketones. Treating with sodium. So RCO releasing H2 gas or bubbling of H2 gas, that's also an observation. A, B, D correct. 170, answer 5. (171) Propanol has a higher boiling point than, again, propanol and propan 2-ol. Dipole hydrogen bonds. Hydrogen bond is stronger, so the higher boiling point is supposed to go on to propan 2-ol. Hydrogen bonds are stronger than dipole interactions. The carbon-oxygen double bond in propanone is more polarized than the carbon-oxygen single bond in propan-2-ol. Yeah, this is more polarized than this. You guys know that single bond is moving, not moving. Sigma bonding just staying stationary. But pi bond is the one which is moving. Sigma bond electrons do not delocalize to pi bonds. Only pi bonds delocalize easily. Oxygen is more electronegative, so polarizes towards itself. That's possible. 171, answer 4. Hundred and 72, lowest solubility. Okay, ether we know really water insoluble, that is the greatest. This is white precipitate definitely. Then the next one is that these two, as we know, these are sparingly soluble. Then I'm going to go with these two. Sorry, number 4 is this. Number 4, phenol. The highest soluble one is CH3OH. Okay, they are not asking that. 172, answer 1. You can go with the order and check why it is going through this order. See, number 1 is the only non-polar, no hydrogen bonds. All the other 4 are making hydrogen bonds. That's how we got the answer as number 1. Going with the order is really harder for your syllabus. I've just given you guys a little push. You always need to touch a little advance of chemistry so that it's going to be really easy to answer our paper. Okay, 173. Difficult, supposed to be tertiary one. See, this is secondary, primary, secondary, primary. 173, this is a tertiary one. Answer 1. 173, answer 1. Okay, 174. You can use any of these dehydrating agents, but alcoholic KOH, what does it do? Alcoholic mean elimination. With alcoholic KOH, you get the double bond. That's elimination reaction. 174, answer 5. Which of the following reacts most rapidly when mixing with glucose? Most stable carbocation, SN reaction, going through this most stable carbocation. So This, see, this is allyl group is here, but oxygen, OH joins to this carbon, so that's only primary, and this is tertiary, this is secondary, this has tertiary plus this allyl system as well. Tertiary and allyl system together. 125, answer 1. I'm showing here how it is going through the resonance. See the plus charge is moving to make this carbocation more stable. Plus charge is here initially and finally here. (176) again, carbocation stability directly asking. I'm starting with this ring deactivator. These two are exactly same. A and C exactly same other than NO2. Then A, but this is more stable with 3-benzyl carbocation. 176, answer 2. (177). This is extremely easier. You have this single 2-butanol oxidizing to ketone, leave it there, PCl3 to haloalkane with Grignard. Then you are mixing these two together. This C minus is attacking onto this carbon. CO bond is dissociating onto oxygen, then converting to OH. So CCCC. CCCC. Then this part is this. This part is this. Is that clear? They were just playing with like showing these carbon in different ways. So when you are doing aldol condensation, these two carbons are not getting adjacent to each other, but when you are doing Grignard, two carbons always come together. Remember that when you are doing conversions, if two carbons join together, label or some sort of that's coming through Grignard. Increasing order of solubility. Definitely alkyl halide is D. See the alkyl halide. D is alkyl halide. Then moving to C, dipole-dipole interaction. Then if you are moving to A and B, so B is supposed to be the greatest because carbon chain is shorter. This carbon chain is shorter, but here you have more carbon, so more water repelling. 178, answer 2. Amaya, are you comfortable with this? Nadija, are you comfortable? Tony? Okay. Usiru? Arham even haven't done these questions at home. But he's always doing a couple of questions ahead of me and he's checking with me with my answers as well. You can try that if you want. Being little more like, concentrating. He's going back and forth. He does on question, then come back to its right things I'm saying. Question number 179. 2-methyl-2-propanol. Once you draw these structures, see the nomenclature. And this is tertiary and this is primary. Lucas, this is the fastest, tertiary. Tertiary carbocation has more stable, cations are more stable than primary carbocations. That is the reason through inductive effect. But since this is wrong, answer 4. Less supposed to be more. Underline less and write there more. Less supposed to be more. This less supposed to be more. If so, then answer is 1. Tertiary alcohols, let's move on to 180. Tertiary alcohols react faster than secondary alcohols in Lucas. Yeah, zinc chloride concrete series is Lucas. Tertiary carbocation are less stable. No, more stable than secondary. Stability through inductive effect. Question number 180, answer 3. What is the word you have there? Huh? Just write there. Oh, really? Nobody having anything? I have forgotten. Maybe I guess. That's a printing error. Just less. L-E-S-S. That's supposed to be there. Then the correct one is supposed to be more. Oh, how come I missed that? Question number 181. Which of the following falls about aniline? Reacting with the acid halide to produce this substituted amide evolves ammonia when heated with aqueous sodium hydroxide. This is aniline. This is aniline, not amide. Ammonia releases amide, not with aniline. Bromine water is same as phenol. This white precipitate. Nitrous NH2OH gives phenol true. Less basic than this. Yeah. Because this lone pair on this nitrogen delocalizes it in the ring. It's not happening here. So you have extra CH2 here. Lone pair on nitrogen of aniline delocalizes in benzene ring. So that decreases electron density on nitrogen, therefore less basic. But in aliphatic amine, electron density increases by CH2 group with inductive effect as well. 181 answer 2. (182). Which of the following react with phenol? Yeah, A, bromine, aqueous KOH, yeah, potassium salt, aqueous potassium bicarbonate. Phenol acidity is not enough to react with the sodium carbonate or bicarbonate. And this is phenol. This part is phenol. Okay, this is another phenol. And this is the formaldehyde part. Okay, these hydrogen and oxygen, these three are getting away. So they are making this 3D structure, which is called the bakelite thermostat, which we cannot repeatedly apply temperature using as thermal insulators. We're going to do this under unit 14. That's why I'm explaining it again. because we need that for unit 14. Question number 182. A, B, C, correct. Answer 5. No, time. Yeah, 12:28. Let's finish this page. (183). Consider the compounds A, B, and C. Addition of sodium hydroxide will convert only sodium hydroxide or Na. This, yeah, not C. Sodium hydroxide cannot react alcohols. Alcohol base acid is less. So for 5, sodium carbonate, sodium bicarbonate react only with COOH. That's only B. 183, answer 1. 183, answer 1. Why, happy? Huh? Are you cold? Are you cold? Why? Because? Why? No, what is the reason? Because the battery is not good, I guess. Then? No, I think a program is going on or something's supposed to going on. Otherwise, it's not happening. Keep it on off for some time. Once I got this tab long ago. It's like 5,000 or so. That was extremely cheaper. Then I ordered a couple of for my kids, my sisters, nieces. But within one whole week, all these batteries were blasting. Batteries were feeling like pillows like this. So breaking this two sides, moving these two sides apart. When I was taking these, luckily I didn't give them as gifts. Within 1 week, they are doing such, proud stuff. Anyway, done for the day. Next week, let's start from 184 or otherwise. Are you guys free to send this Colombo recording again? Honestly, otherwise, if you feel like uncomfortable, I wouldn't do that. I know you had fever, he has dad's conditions as well. Raise your hand if you are not able to complete the next Colombo recording. I would send them then. Yes or no? You want it or you don't want? Okay, only for this week, Saptala. Okay. No recordings this week. Okay, next week I'll try to send one because I want you guys to come exactly to this Sinhala medium students level. Okay, bye. Take care, everybody. It's at 9.